math scholars, good to have you here again. This is Teacher Faith, and I'm excited to have you in class today. All right, today we're learning something very, very interesting, something you already know, but you might not really know that you know it. Let's get right into it. I have a set of number on the board. You can see 1, 5, 9, 13. Now, I need you to do something for me. Based on the set of numbers you can see on the board, can you predict what the next number will be? Okay, I have 1, I have 5, I have 9, and I have 13. What do you think the next number will be? Pause and think about it for a second. All right, the next number obviously should give us 17. I hope you got that. I hope you got that. It should give us 17. Please, if you did, please drop that in the comment section that you got this, right? Then what should be the next number after 17? Let's just take it a step further. What do you think the next number will be? For me, it will be 21. The patterns of number, the definitive patterns of number in mathematics. And mathematics has done us well to give it a name. It is called sequence. So we're going to be talking about sequence in the next few minutes. And I know that by the end of this class, you should be able to solve any question or almost any question on the sequence. All right, let's get right into it. Now, for the sake of definition and giving you formula, I want us to derive the formula together. But let's look at this. Assuming or suppose that we give this first figure, which is 1, our first term. Let's call it our first term A. First term A. T1, first term. Then the second one, second term, of course, T2. Then 9, which is the third term. 1, 2, 3. We have it as what? T3. And then it keeps going like that. Don't forget I said sequence talks about predictive patterns in mathematics. Now let's look at it this way. If you notice, for those that were able to get it, one of the things you will find out is that for you to move from the previous one to the next number in this set, all you just need to do is to add 4. Did any of you notice that? I started with 1. For me to get 5, all I needed to do was add 4. 1 plus 4 gave me 5. That's T2. For me to get 9, all I needed to do was to add another 4 to my 5. That's what? 9. That's 1 plus 4 plus 5. You might ask me, why do we have 1 plus 4 here? It's not supposed to be 5 plus 4. Yes, you're correct. It's supposed to be 5 plus 4. But instead of writing 5, I imputed what 5 meant here. 5 here equals to 1 plus 4. So I brought this as 5. So this itself is 5. So 5 plus 4. Do you understand that? Then for the next one, which is 13, the same thing. 13, for me to move from 9 to 13, all I needed to do was to add 4, right? 4. 4 plus 9 gave us 13. Now, instead of writing my 9 again, I decided to split it and write what it meant here. I had 1 plus 4, which is what 9 is here, and added my last 4 to give me 13. If I decide to get T5, don't forget we stopped at T4 here. T5, T6, T7, and down to Tn. Tn means that you can impute any number in that n. N there simply means number. All I need to do is to follow the same pattern. Already from here, you can see the increment plus 4, plus 4. We wrote this, we added 4. The next one, we write this, we'll add 4, which is T5. You will notice something. There is a common difference. And what does that mean? 5 minus 1 will give us 4. 9 minus 5 will still give us 4. 13 minus 9 will give us 4. Our next number, which is 17, if I decide to subtract 4 from it, I will still get 13. Now, that is what we call common difference D. And based on the set of numbers I have here, our common difference is 4. Of course, for some other set of numbers, it won't be 4. It can be anything. It can be -2. It can be +10. It can be anything. All you just need to do is look at the set of numbers, identify the pattern, and you'll be able to get your common difference. So for us to get the equation, there are 2 major things we need. Because if you look at this, one thing is consistent in all of this. We have 1, 1, 1, 1, and that's how it will keep going. It won't change, even till Tn. And I decide to represent our T1, which is our first term, with A. I hope you understand what I'm saying so far. Please, if you don't, all you just need to do is pause the video and go back and learn. Now, for those that are following, now to continue with our formula, I told you that one of the things that has been consistent all through is our A. I decided to exchange the 1 for A. I said where T1, which is our A now, first term, equals to 1. We don't have any issue with that. And our common difference D equals to 4. I'm trying to get the formula, don't forget. Our T1 will bring it as A, 1. Then the T2, what do we have? A plus common difference D. A plus D. Our T3, what do we have? We have A plus D plus D. When you add the two D's together, you have A plus 2D. If we try to get Tn, and like I said, nth term, that's the meaning of Tn. Nth term basically means that we can impute any number. So instead of continuing with this sequence and keep writing it, for example, if I ask you to get the 100th term, instead of continuing this till we get to 100, we're trying to come up with a formula that can help us and make that easy for us. Now let's look at this. What you will notice is that the relationship between the nth term and the D, between the nth term and the number of D's that we have, number of common difference. Let's look at the first one. You might not really notice anything in the first one, but let's look at this second one, which is T2. We are looking for T2 and we have 1D, right? Have you seen the correlation? We are looking for T3, yet we have 2D. We are looking for T4, yet we have how many D? 3Ds. That means it is minus 1 of the number of nth term. Minus 1. If I'm looking for T100, how many Ds do you think I will have? Drop that in the comment section. Alright, if you got that correctly, it means 100 minus 1. I will have 99 Ds. So from there, let us come up with a formula. Let's say this one, since we have 2, we can also write this as A plus 2 minus 1 D. We can write this as A plus 3 minus 1 D. We can write this as A plus 4 minus 1 D. Now you will ask me, if it's a formula, it's not supposed to be consistent with all. Yes, we can also write for the first one. How about to write T1 to be equals to A, this is A, not 9, please. A plus 1 minus 1 D. And we multiply that by D. Anything multiplied by 0 is what? 0. Do you understand? And that is why it's looking like there is no D here. In fact, with this, we've gotten our formula. It means if I have, what's it called? If I have nth term, if I have a question and it is nth term, all we just need to do, based on the patterns, if you look at it, consistent pattern, 1 is here, 1 is here, 2 is here, 2 is here, 3 is here, 3 is here. Let's move to our n. We can also say Tn equals to A plus, please echo it with me, n minus 1 D. Do you understand? How did I get my n? I noticed from my pattern, from this simple sequence, and it is the same for all sequences, from this simple sequence, that all I need to do is get my first term and get the common difference. Once I have that, I can get any term of the sequence. One of the things that we can see from this example that we were able to explain here is that for every term that we have, all we need to do is add the first term and the term minus 1 times D. Don't get confused. This is it. For any term, add the first term, which is our A, plus this is the n again, plus the term minus 1. So n minus 1 times common difference. Should we try that for, let's say this is the first term, second term, third term, fourth, fifth, sixth. Let's try that for sixth term and let's see if it works. At least this one we're able to get ourselves. And you can also try it for maybe, let's say, 20th term. If you can do it, just try it and see if it will work, right? In fact, I challenge you to try that and write it for me in the comment section. So let's do for the sixth term. We'll have T6 equals to our A. We already have our A. A is the first term. Our A is 1. plus, what is our n? D6. 6 minus 1 times d. What's our common difference? 4. With that, let's solve it to have T6 equals to 1 plus 6 minus 1 gives us 5. 5 times 4. Let's put this in brackets so that it will be easier to understand. We have T6 equals to 1 plus 5 times 4 gives us 20. Then we have our T6. Please, it is not T6, like it is not T times 6, it is T subscript 6. So you just write it down here. So our T6 therefore equals to 21. Can you see that what we have is the same as what we originally got? It's that simple. Can you see that it is simple? All that this formula is doing is to help you and make your journey easier, simpler, and faster. So from this, I can get the 100th term. Do you think we should try that? All right, try that and let me see what your answer is. Drop your answer in the comment section. We want to get the 100th term. So we have T100. Someone will look at it and say, Teacher Faith, this is so big. Don't worry, let's get it done. All we just need to do is, anywhere we see n, replace with 100 and input our parameters. Don't forget again, our a is the first term, which is 1. So our a is 1 plus, what is our n? 100 minus 1. What is our d? Common difference 4. This will give us what? 1 plus 100 minus 1 will give us 99 times 4. All right, this will give us 1 plus 396, which will give us what? 397. I hope you got this answer. All right, in the next class, I will see you as we solve some more questions under sequences. Now, notice that usually when they ask questions, it might not be as direct as getting the 100th term, the 13th term, the 15th term. So in the next class, I will show you, especially WAEC standard, of how questions under sequences are being set, how they are being solved, and what the marker expects from you as a student. See you in the next class.